Hi to all. Now I am going to explain cauchys formula, and after this cauchys formula I explain dispersion and why the dispersion takes place, and next what is angular dispersion, what is the dispersive power of a prism, and that all things I am going to explain. And you listen very carefully. Right? And the first one is the cauchys formula. What is cauchys formula? It gives the it gives the relation, it gives the relation between refractive index of medium, refractive index of medium and wavelength of light, wavelength of light. Okay, the formula is that nu is equal to a plus b by lambda square. The formula in this, nu is the refractive index of medium and lambda is the wavelength and a comma b are the constants. Now see here, in this, if lambda is less, then refractive index is more. If lambda is more, and then the refractive index is less. Now different colors having the different wavelengths, you know that different colors having the different wavelengths. Different colors have different wavelengths. Different wavelengths. Due to that, we know that the violet color has the less wavelength comparing to the red color. Due to that, the refractive index of certain prism or the medium for the violet color is more than the refractive index of the red color. Okay. Lambda V is the wavelength of violet color light. Lambda R is the wavelength of red color light. Okay, right. And this is about Cauchy's formula. Different colors have the different wavelengths. Due to that, the medium refractive index is also different. Okay, we know Snell's law also. What is Snell's law? According to Snell's law, we know nu is equal to sin I by sin R. From this, for a given angle of incidence, the nu is inversely proportional to sin R. That means angle of refraction depends upon the refractive index. R is the angle of refraction and nu is the refractive index. Okay, refractive index depends upon the angle of refraction or the angle of refraction depends upon the refractive index. And next D for in case of thin lens, in case of thin prism, what is the deviation angle? Deviation angle is nu minus 1 into A, where A is the angle of prism or the refracting angle. If refractive index, here we know the lambda of violet color is less than the lambda of red color. Due to that, the refractive index of violet color is more than the refractive index of red color. If refractive index of violet color is more from above formula, if nu v more, then nu more, delta is also more. That's why deviation angle of violet color is more than the deviation angle of red color. Different colors bends with the different angles. Okay, if they incident on the refracting medium. Let us see, and you take the screenshot and note it. I am going to erase this and I will continue. Let us see what is dispersion. Dispersion is the phenomenon of splitting of white light. The phenomenon of splitting of white light into seven colors is called as dispersion. Now let us take this is a prism. This is a prism. And now one light ray is allowed to incident on the prism. This is a light ray. We can take another color. One light ray is allowed to incident it here. For example, this is the white light. When white light is allowed to incident it here, if there is no prism, it will go in the straight line like this. But due to the prism, it will bends. And the different colors will bend with the different angles. Now you see here, it will bends like this. And all the colors will bend, different colors will bend with the different angles like this. If you keep one screen at here, screen is nothing but white paper. Okay, and then on the screen you observe the different colors. We will observe the different colors. First, you observe the violet color. This has names. There is a VibGR, V I B G Y O, and last one more color it will form. That is the red color. And then here, if you will see that the deviation angle of the violet color is bending more. The deviation angle of the violet color is more at here. And the deviation angle of the red color is less. From the figure you see that dif- different colors will bend in the different angles here. If you will extend it here backward, this is the deviation angle of the red color. And now You can do the extension of this one, and this is the deviation angle of the red color. Sorry, the violet color. And from the figure here, why the dispersion is occurred? Here, white light is split into seven colors. This is called as the VIBGR. Okay, VIBGR is the colors. In that, why the white light will split into seven colors? The reason is what? The reason is that the white light has the seven colors. Then for seven colors have the seven different wavelengths. That means white light has white light has seven colors, and these are having different wavelengths. These are having different wavelengths. These are having different wavelengths. The refractive index of prism depends upon refractive index of prism depends upon wavelength. Due to that, different colors deviates with different angle. Due to that, dispersion takes place. What happening is here? Actually, lambda changes. When lambda changes according to Cauchy's formula, nu changes. Different prism has different refractive index for the different colors. White light has the seven colors. Due to that, wavelength will changes. All different colors have the different wavelengths. And then nu changes. When nu changes, automatically deviation angle also changes. And the different colors will bend with different angles. Lambda of violet color is less than the lambda of red color. That's why the refractive index of violet color is more than the refractive index of red color. And that's why the deviation angle of the violet color is more than the deviation angle of red color. Okay, right. This is about dispersion. Next one is you take the screenshot and next topic is what is angular dispersion. Different colors when the light rays are incidenting. When the white light will incident on a prism, at that moment the different colors are bending with the different angles. We are observing like this. This is the screen. This is the violet color. This is original path. And another light ray we will take. This is the red color. In this, in between them, other colors will be there. There is some angle between the two colors, right? And for example, this is the red color, and this is the violet color. There is an angle between them. This angle is called as angular dispersion. Angular dispersion is nothing but angle between or angular separation between, we write like angular separation between any two colors. Angular separation between any two colors. Any two colors is called as angular dispersion. How you will get the angle between any two colors? Angular separation between any two colors, as shown in the figure. This another definition also there. That is the difference between the difference between deviation angles of the difference between deviation angles between the difference of deviation angles, okay, deviation angles of any two colors is called as angular dispersion. These are the two definitions of angular dispersion. I will explain what is angular dispersion. You see here, it is angular separation between the two colors. It means angle between any two colors only. Okay. Now, the violet color, for example, this is the original path. This is the original white light path. And here the violet color is deviated like this. And the red color is deviated like this. Okay. And this is the deviation angle of the violet color. And this is the deviation angle of the red color. And when you will subtract these deviation angles, we will get the angular separation between the two colors. You see the picture clearly. Okay, this is the white light. And the white light will split into different colors in here. White, violet and red. You see the figure. This is the white light. The white light original path, this one. But if the prism is there at here, due to the prism, what happens? It will split into seven colors. This is the violet and this is the red color. Violet color bends with an angle delta V, and the red color bends with an angle delta R. Okay, when you subtract these two angles, deviation angles, delta V minus delta R, we will get this part, right? That is theta. Then from the figure, angular separation we write from figure, right? Angular separation is nothing but angular dispersion. Angular dispersion between angular dispersion between violet and red colors. What is the angular dispersion? That is theta. We write theta as like this: delta V minus delta R. But what is delta V, right? Delta V is the deviation angle of violet color. We write like this: nu V minus 1 into A. Because we know formula for the delta is nu minus 1 into A. Here we write it. This is angular dispersion 1 formula. And delta R also we write, that is nu R minus 1 into A. If you substitute in above equation, then we will get angular dispersion final formula. This theta is equal to nu V minus 1 into A minus nu R minus 1 into A. What is nu V? When you will simplify this, okay, after the simplification we will get nu V minus nu R into A. Okay, this is one more formula for the angular dispersion. Okay, nu V is the refractive index of prism for violet color, and nu R is the refractive index of prism for red color. Okay, right. Now you note it, and I will continue. The next topic is dispersive power. What is dispersive power? Okay, for that you take the screenshot and note it. I'm going to erase. Next topic is dispersive power. What is dispersive power of prism? Dispersive power means splitting power. Dispersive power of prism. Okay, it is nothing but it is a ratio between angular dispersion and mean deviation between any two colors is called as dispersive power. I will write the definition. It is the ratio between angular dispersion. It is the ratio between angular dispersion between any two colors to the mean deviation angle between any two colors is called as dispersive power. Now the dispersive power formula is, it is denoted with omega. Dispersive power omega is equal to rate is angular dispersion by mean deviation angle between any two colors. For example, if you take the only two colors, that is one is we will take as violet and red color. Angular dispersion formula is delta V minus delta R. And the mean deviation angle means deviation angles. Angular dispersion formula previously we discussed, that is delta V minus delta R. And mean deviation means delta V plus delta R by 2. This you will get. And this is the formula for the dispersive power. Angular dispersion is more, then the dispersive power is more. Dispersive power is more means then the separation between the colors is also more. Okay, and now we write here, but delta V plus delta R by 2, it is nearly equal to delta Y. Delta Y is the deviation angle. What is the mean deviation actually? The mean deviation means average deviation, right? The mean deviation is nothing but deviation angle of yellow color. Okay, right. That we substitute in above equation. Then we will get delta V minus delta R by delta mean we have to get, but delta mean is equal to delta Y. Okay, deviation angle of yellow color. But we know delta V minus delta R, right? But angular dispersion is equal to delta V minus delta R. It we simplified, we got as nu V minus nu R into A, that is angular dispersion. And delta deviation angle of yellow color we write as nu Y minus 1. If we substitute in above equation, then angular dispersion we will get another formula. That is nu V minus nu R into A by nu Y minus 1 into A. This A gets cancelled, and finally we will get the formula for the dispersive power, that is nu V minus nu R by nu Y minus 1. Okay, this we can also write as delta V minus delta R by delta mean deviation angle. Okay, right. This is about dispersive power and their formulas. Thank you for watching my lectures. Till now, if you not subscribe, then subscribe and share to your friends.